Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Izzuan bin Ishaq. I'm from Faculty of Science. Today I will present a new modified conjugate gradient method under the strong Wolfe line search. This is my presentation outline. Consists of introduction, problem statement, objectives, scopes, literature review, method, result, and lastly conclusion. So start introduction. Optimization. What is optimization? Optimization problem deals with the basic concept of daily life to achieve desired objective, which is it will deal the problem of maximization or minimization of a certain objective function. Then optimization problem classified into constrained and unconstrained. So in this presentation, I will focus on unconstrained optimization. Many different algorithms has been introduced to solve the unconstrained optimization problem. So they have a few main classes of algorithms for unconstrained optimization, which is Newton, Cauchy-Newton, step's descent, and conjugate gradient. So I will focus on conjugate gradients because it considered as one of a successful algorithm for solving unconstrained optimization problem. Okay, on the problem statement, we formulated the optimization problem as following. The function is twice continuously differentiable. It's called objective function. This involves finding the optimum vector x denoted by x star over all possible vectors in C. So our objective to improve the performance of conjugate gradients. Second, to create and develop the proposed modified conjugate algorithm for unconstrained optimization. Third, to analyze the convergent behavior of the proposed modified conjugate gradient under line search. And lastly, you want to compare between the numerical performance of the new modified conjugate gradient and the existing modified conjugate gradient in terms of number of iteration, number of function gradient, and number of CPU time. This is our scope: unconstrained optimization, conjugate gradient method, strong Wolfe line search. Okay, first in literature review, Hastings and Stifel developed conjugate gradient in 1952. It is the improvement to the steepest descent method. They are focused on symmetric and positive definite linear system. This is the beta that Hastings and Stifel introduced. Then, on 1964, the formula of Fletcher and Riff is usually considered the first nonlinear conjugate algorithm since the paper focuses on nonlinear optimization. This is the conjugate gradient development. 1967, proposed by Pollard and Rebray and by Polyak. 1987, proposed by Fletcher. It's called conjugate descent. 1991. Proposed by Liu and Story. 1999, proposed by Dai and So, in 2012, Rivai et al. Suggested a new simple beta applicable in which defined by the following beta RML. They retain the original numerator as the PRP, HS, and RS formula to give it restart properties. After that, on 2016, another modification based on PRP method proposed recently Hamoda et al. Named HRM. The formula are shown as below, and the value of parameter mu can be set to 0, range 0 to 1. So we proceed to the method, which is conjugate gradient. It was originally developed as a direct method but became popular for its properties as an iterative method. It is also popular because of its properties. Is a low storage requirement and inexpensive algebraic cost, which is faster convergence than the steepest descent. Okay, this is the conjugate gradient algorithm, which is generated iteratively. So we use in exact line search, which is strong Wolfe line search, to find the step size in order to get the global convergent properties. This is the two the two conditions that we need to follow. We use strong Wolfe power line search because it doesn't need expensive computational work to find the best step length. So this is our proposed algorithm. Based on properties of R-mill and HRM method, a new modified beta, which is known as beta ISL, was proposed. This is our proposed method. This is the algorithm. So we continue to the result part. The computation experiment was run on a MATLAB program consists of set of 68 unconstrained optimization test problems and 20 test functions. The proposed algorithm is compared to the three conjugate gradient method. The proposed algorithm compared to the three other methods, which is Fletcher-Riff, Ambry, and HRM. For each test function problem, we use 4 initial points. This is a list of test functions, consists of a few dimensions and 4 initial points. Okay, from the figure 1, this is the result which is performance profile relative to the CPU time. If you look at the y-axis, you saw the ISL graph is performed better other than method. How you can see it? The higher the value of y-axis on each method, the performance is depend on it, which is the greater the higher. So it's very clear that ISL method is the winner on the CPU time. Okay, so we continue to the performance profile relative to the number of iteration. We can see here ISL still the winner compared to the other method, but on the number of iteration it's quite hard and tough competitive with the other method, but still ISL managed to top all of them. Okay, from both figures, it's clear that ISL has the highest probability of being the optimal solver. The percentage that ISL is the winner on a given problem is 48%, which is the fastest time. HRM and Ambry quite competitive, but they can solve about 38%, but they are quite slow in terms of CPU time. Okay, we go for the conclusion. From the research, it gives a new conjugate gradient method for solving unconstrained optimization problems. Under the strong Wolfe line search, this beta possesses the global convergence condition. From the numerical result, it shows that our method ISL is the best compared to the other three conjugate gradient method, HRM, Ambry, and FR. Thank you.